Since all the state changes goes through the single controller of Cerebral, it knows everything that is happening in your application. This allows us to give you some powerful tools, like the Cerebral Debugger. We are looking at the traditional to-do MVC application running on Cerebral, and next to it we have the Cerebral Debugger, which is a Chrome extension. Currently it shows that one signal has triggered in the signals list, and that signal was caused by a route change. The signal has a color, and this color is based on the full name of the signal. That means signals within the same module will have the same variance of coloring. Next to the signals list we see the execution details of the currently selected signal. The execution details shows us what actions were run, what changes has been done to the model layer, what services has run, and what inputs and outputs has passed through the signal. When I now change the input of the application, we can see that new signals are added to the list. Since the signals are of the same type, the list will automatically group them together. To expand the group, you simply click it, and click it again to collapse it. When I hit Enter now to run a more complex signal, we can also see a signal with asynchronous actions running. This is indicated with a pulsing signal in the list. Looking at the execution details, we see that the asynchronous action is called save to do, and its execution has been put into a box. This indicates that any other actions in the same box would have been run in parallel. Typically, asynchronous actions chooses a path based on the result of the asynchronous operation. The save to do action chose the success path and then ran the update to do action. It could also have chosen the error path, but in this execution it did not. When a signal has asynchronous actions, it means that the other signals might trigger during its execution. Let us add a signal with an asynchronous action again and immediately add some more signals. As you can see, these new signals has an indentation in the signals list, indicating that they are part of a currently running execution. The debugger gives you a lot of information about how your application has executed, but it also gives information about the current state. Let's click the model button and take a look at our state. This application has three namespaces: app, refs, and recorder. When I click the app now, we can see the current state of the application. When I make changes to the application, we see that the model updates live. But we can also go the opposite direction. When I now click the title and change it, the application will actually update. Moving back to the signals list, we can see a new signal was triggered, and it was triggered by the DevTools. This is a perfect example of how everything in Cerebral is just signals, actions, and services. Any module you bring in from the ecosystem will be completely exposed in the debugger, giving you great insight into everything that is happening. But let us explore this signal list a bit more. First of all, you can look at signals that has previously been run by clicking the signals in the list. But you can also look at your application at a specific point in time. By double-clicking a signal, you reproduce the state of your application at the specified signal. As you can see, now my added to do is gone, and I see the input I had typed up to this point. We can even remember the manual model change we did. When you move back in time, your application is locked. Any signals you produce will actually be ignored. To continue interacting with your application, you have two choices. You either go back to the last signal, or you can rewrite history. By hitting rewrite from current signal, you will clear out all future signals, and you are free to interact with your application again. You can also reset the application, removing all signals run and put your application in its initial state. By default, this happens every time you refresh the browser, but you can prevent that, allowing you to make code changes and reproduce the state of the application on refresh. By unchecking reset on refresh and producing some state, we can see that a refresh puts our application in the same state as it was before. So thanks for taking a look at the debugger, and please move on to more documentation and videos as you explore the Cerebral website.